All right, hello, my wonderful students. This is foldable number 6, the dreaded number foldable 6. This is the super long one. Well, not really. I'm going to space it out so I don't have to do 2. This is for section 4.3, using a polynomial function to maximize volume. All right, we're going to zoom in a little here, and we are going to be going ahead and going all the way through there, so we won't have the whole thing throughout the whole thing there. But I just lost a little bit of focus. There we go. So it starts off, the design of a digital box camera maximizes the volume while keeping the sum of the dimensions at 6 inches, which is important information. If the length must be 1.5 times the height, what should each dimension be? So we got to do this slowly first. So we got to define the volume. Well, you know what? Let's just go ahead and let's go ahead and define the volume. So our volume, we know, is going to be equal to what? It's equal to our length times our width times our height. And right now we don't really have what each are. We have that, the length, it must be 1.5 times the height, so it has to be 1.5 times bigger than the height. But it doesn't actually give us information about the width. But the key term here is the sum. So the first thing we're going to do after, well, I guess it's the second thing because we did this one first, is we're going to define a variable. A variable. Okay? And from all the variables that we saw, you know what I'm gonna the only one that has a relative is the height, because the length must be 1.5 times the height. So we can't really do this, or else we'd hit the divide by 1.5. So what we're going to do is we're going to let the height, or let x equal the height of the camera. Okay? So now we have, at least the variable defined is just the height. So now we have to determine, so part 2, we have to determine the length and width. Well, the length is pretty easy, because if we have that the length must be 1.5 times the height, then we just get the height, which is our x. So let's write it over here. So our h is equal to x. That means our length, just using L, is equal to 1.5 times our height, which was x. But the width is something we really have to think about. So our width, I just put W for width, is, we don't really have any information here about our width, but we do have that while keeping the sum of dimensions at 6 inches. That means the length plus the width plus the height must equal 6 inches. So if we know our, so let's do that over here. Let's do a little side note. We'll do it in red. It says our length plus our width plus our height must equal 6 inches. So we know our height is x. We don't know our W. And we know our length is 1.5 times x. And this is all equal to 6. So let's go, x here. So let's go ahead and combine like terms, and then we'll solve for W. So 1.5x plus x would give us a 2.5x plus W equals 6. Then we can go ahead and subtract 2.5x to both sides to get the W by itself. When we get W is equal to 6 minus 2.5x. So now we have our W. We don't actually know what it is, but we at least have it in terms of this. So W is equal to 6 minus 2.5x. So now we go ahead and determine the thing. Now we can find our volume. So we'll go to 3. Our volume. And we already found the volume up here, right? We found it that the volume is length times width times height. So our volume, our V, is equal to length times width times height. And now we know all 3. We have all 3 here. So our length is 1.5x. Our height is, our width is 6 minus 2.5x. And our height is just simply x. Now I'm going to use my wonderful calculator. I'm going to go beep, boop, 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 boop. And I'm going to find that our volume is actually equal to negative 3.75 x cubed plus 9x. And of course, I didn't actually use my hand. I actually plugged this into a calculator beforehand, so I'd be ready for you wonderful, wonderful people. So the next thing we're going to do is we're going to graph. So I'm going to use a different color. She's going to use black. So our fourth one is we're going to graph this polynomial. Polynomial. I don't know why I put a space there. Sorry about that. Function. Not supposed to be a space there. And then we're going to use the function, or use the graph, the maximum, to find the max volume. Oh, we're going to use the trace, actually. Trace, but then we're going to go to the maximum to find the max volume. And I know it doesn't say it, but we're talking about relative max, right? We're talking about the relative max of this one. So we're going to go ahead and take our calculator. Let's go a little bit this way so we don't have to glare. Turn it on. There we go. We're going to go to Document, File, New Document. No, we do not need to save. Go to Graph. We're going to type in our graph here, down here. So we have negative 3.75 x to the third power plus 9x. Go ahead and push enter. And we're going to get this crazy wonderful thing. And once again, our maximum technically is all the way up there. But we're going to actually use our trace button. And you know what? I'm just going to play around real quick to see if they might have a max or a min button, because I actually didn't really look at it. So if it's not under trace, let's try analyze graph. Oh, okay. So let's see maximum. And we're going to look at the maximum of this graph and this graph. Nope, it did not work out. So we're going to go ahead and go menu, go to trace, and we're going to go to our here. Oh, highest point we can find there, which is at 0.9. And I know it doesn't say max on this one, but it's okay. It'll be our 0.9 part. So our relative max for this one would be at 5.37. Not plug that in, sorry. We have to plug in so we found our relative max. Now we're going to go in and actually find our height, our width, and our length. So we're going to go ahead and just write what these are really quick, and then we're going to go back to the graph so I can show you what they are. But I wanted to put these in first. So our height was x. Our width was 6 minus 2.5x, and our length was 1.5x. So we're going to go back to the graph, put it back on our maximum. So if we were to go down to our positive 0, we get that our x is 1.55. So that is actually going to be what our x is. So it's going to be equal to 1.55. So our height is 1.55. Move up a little bit. Then we have to plug this in here. So we have 6 minus 2.5 times 1.55. And then we can go to the calculator and actually plug that in as a new document. No. Go to the calculator. So we go here. We get 6 minus 2.5 times 1.55, and we get equal to 2.125. And then we go ahead and plug in the next one, which is 1.5 times our 1.55, and we get 1.5 times our 1.55, which is what we're substituting for x, and we get 2.325. So these are our dimensions. They're going to add up to 6.